Ano sabon. Okay.
Sabon. Stop playing. I'm going to.
Daddy. Yeah, found it.
Yambala mogende waje.
You see.
Perfect.
Wait a minute. Hello.
Don't say hello to students.
Oh.
Students. Hello guys, finally we are here. I've struggled. I think maybe it's the network interruption because of the rain. But let's get started.
It's rained.
I know. We are going for class.
Even me.
Can get your tab.
My tab. Are you sure?
You want to become a physicist?
Let's have a tab.
If you want to become a physicist, keep quiet.
Glasses. I love glasses. Colesa. Olaba bulungi sooka olabe nze. Nkola bwe bati nze ndaba bulungi. Sooka olabe. Nze nkulaba.
They can be good. Let me first teach, okay? Be a good boy, right? So guys, yesterday the other time we had discussed the pendulum, how a ballistic pendulum operates. So let's have an example. You see how I'm writing? A bullet.
What?
A bullet of mass. I don't touch my phone. 40 grams is fired. Guys, sorry, the issue of network is real. I'm now shifting places. So I was giving an example that a bullet of mass 40 grams is fired from a gun at 200 meters per second. And Rebecca. extension one away. Hajat. Hajat. Rebecca. Jagala the extension one deal in Temu and in Tiwa.
Oh.
Issue of network is real. Okay, you have that. We are saying a bullet of mass 4 octagrams and is fired from a gun at that speed. Then we are saying hits a block. It's a block of mass 2 kgs, which is suspended by a light vertical spring. A light vertical string, 2 meters long. 2 meters long. We stop. If the bullet gets embedded into the wooden block, calculate A, the maximum angle the string makes vertical. Then B, state the factors on which the angle of swing depends on. Have that question down. Because of interference of network, you already have the question with you. So capital M, small m is 40 out of 1,000, which is 0.04. Let U be the velocity of the bullet. Then V be the common velocity just after impact. Now what happens is we shall have the string this is the bullet, this is the block. And the block will rise some distance. Yes, China, thank you. Connecting. Students.
Bye.
Silence. So if the block rises to that height, It is going to rise with a bullet embedded inside it.
Sally, look to my shirt.
Now it's going to rise to a certain height. We shall assume this height is 8. Connect to Halimunda. Also put this one. Sorry guys, let's first connect. My battery will run down, so I have to first be secure. If you are here, you keep quiet, you're in class, okay? So if the bullet has been risen to that height, the bullet was moving in the usual velocity u. On impact, they moved with a velocity v. So when they come up here, v becomes 0. Now with that reason, momentum conservation, mass of the bullet plus 0 momentum for the block, because it was initially at rest, will give us the momentum after, which will be combined momentum with a common velocity v. So with this, we can get their common velocity v. We can get their common velocity v. I don't got to charge it. You can get their common velocity v. It's not hard. By making v the subject, by giving us, by giving us small capital V is equal to capital M. Hey, bring my key. Plus small m. Sorry, no. You know, this kit mixed me up a little, but sorry for that. It's done. So we shall have mass of the bullet, the initial velocity of the bullet, over capital M mass of the block plus small m mass of the bullet. So with this, we shall have 0.04 times 200 divided by 2 plus 0.04. When you simplify this with a calculator, what do we attain as their common velocity immediately after impact?
I have to make my calculator.
What do you get? We get? Calculators. Guys, can you give us an answer? Kasacha, I see you unmuted. What's your answer? Eh?
3.92.
3.92 meters per second. So that's their common velocity just after impact. Now, you know energy conservation. Just after impact, they possess kinetic energy just after what? Impact, which will be given by a half their total mass times their common velocity, which will give us a half times 2.04 times 3.92 squared. Calculator, what answer do we get?
15.67.
Hmm?
15.67.
Close. Now, all this kinetic energy that is going to be lost is going to be
67.
converted into the potential that is going to be gained. Remember, as it leaves this place, it leaves with that common momentum of m plus small m times v squared over 2. So this energy is going to be lost to mg what? H. So we shall have 15.27 is equal to, you said what?
67. 15.67.
Like that, eh?
Yeah.
Okay. Now, this is going to be equal to the total mass times gravity times height. So we can find the height, which is 15.27 divided by 2.04 times, sorry, down here times 9.81 as gravity. So what height do you get?
Zero point 0.78.
0.78.
78.
Now, last time I remember we derived an equation for getting the angle. I don't know that you remember that equation we derived, whereby we saw that theta could be got from cos inverse of 1 minus v squared over 2gl, where L is the length of the string. V is the common velocity they move with. G is gravity. So theta would be cos inverse of 1 minus 3.92 squared out of 2 times 9.81 times the length of the string. The length of the string was given as what? What was the length given? 2 meters long, so times 2. Can you compute that in a calc and give me the answer? Can you get off the bonnet? Get off. Answer for the angle.
Teacher is 52.5.
You get?
52.5.
52.5 point 53. Okay. So that's the solution for that. So the factors which the string depends on: 1, the velocity of the bullet. I mean, their common velocity. Okay, of course we have the common velocity, which common velocity depends on the velocity of the bullet. So factors: 1 is the velocity of the bullet. Initially. Then it also depends on their common velocity after collision. It also depends on the mass of the block, because the velocity depends on the mass of the block. When you look at this velocity here, the bigger the mass, the smaller the velocity, which is common. The smaller the mass, the greater the velocity of their common velocity. Now, if their common velocity is greater, it implies that the angle here will be having a small ratio of cos. So a small ratio of cos gives you a big angle. For example, cos of 0 is 90. Yeah? So that means cos inverse of 0 is 90. So to get an angle 90, you must be having a small velocity. While if you get, for example, cos of 30 is 0.8667. Yeah? While cos of 60 is a half. So the more you go on increasing the angle, the smaller the ratio you get. Okay? Then the other aspect it would depend on, it also depends on the length of the string, because you see L is there, so you have length of the string. Also depends on the length of the what? The string. So I'll also assign you a number which will have a bullet describing a pendulum, having a ballistic pendulum. So you can download that so that you can have another illustration of momentum. I hope to finalize momentum today with some of these numbers I'm going to show you. Ahil, come. Mwe, nabagambye nsomesa sagala kuleka. Yambala mugende bakutwala out. Abatwala ahiriye. Mutuyambadde. Wagenda kukyusa ndowooza. This second question, looking at momentum. This second question is looking at momentum, whereby we have two colliding bodies. I think you've watched pool table. So I was saying, if you've ever watched a pool table game, when people play pool, there is a way they hit the balls and the balls can end up separating. The balls were initially in contact. If someone is to knock a car, if a car comes like this is my car, and comes and knocks two cars which are stationed together, there is a possibility of this car coming to collide and knock them in the middle here, so that this one can divert this side, this one also diverts that side. So they can give you momentum of such a scenario, whereby momenta is acting at different directions. That's why we say in the first definition, in the principle of conservation of momentum, we say that total momentum in a given direction is a constant for a closed system. Why do we say given direction? It's because the direction can be altered at any one time. So we have a number here, example 2. It is of that category. So it has a long write-up. An alpha particle capital A of mass 4 units is incident with a velocity v on a stationary helium nucleus B of mass 4 units after collision M moves in direction BC. M moves in the direction BC with a velocity V over 2. Where BC makes an angle of 60 degrees with the initial direction of AB. With the initial direction of AB. Calculate the angle made in the direction AB and the velocity of the helium nucleus along BD. So they're asking for that angle theta, which it makes with the original direction AB and the direction of the helium nucleus after splitting. So you can have that question down. Let me wrap this other work. Hello? Onkubideko. Omaze. Kati mulagawa. Mulagawa. Kati mulagawa. Bade manyi mwabisazizza. Ani? Boni ya. Kuba ndaba ateeka okuba w'amaanyi nnyo wanzigiddeko mutabani wange. W'amaanyi nnyo wanzigiddeko mutabani. Kale. Musajja ali wano singa omanyi wabadde asireeyinga. Kale. Singa omanyi wabadde asireeyinga. Kale kankute. Ndi waka nsomesa. Kale, next students, now let me have the solution for this number. I hope you're done downloading the question. Mugende muzeyi mugende mugende bakutwala. Mwabajja bachi mu luvannyuma. Now, we can let the velocity of helium be equal to y meters per second. Then, in this case, what is going to happen is we are going to have horizontal and vertical momenta. So initially, this one which was moving horizontally. So we have horizontal momenta. Remember, momentum is a vector. Because momentum is a vector, we shall have both vertical and horizontal components. Hello? Yes, please. Hello, yes, please. Good evening, student. How are you? Hey, what's your name? Hello, what's your name? What's your name? Which school and which class? Form 2. Right now, I'm still in class. You call me again at 6 p.m. After that message, when you see that message, after paying the 50,000, I'll send you the details. But you call me back at 6 for more details. Pardon? You can send it on this number or the MTN line. You can send on this number or the MTN line, but better the MTN line. You can send on this number or on the MTN line. Yes. Call me at 6 for more details. Sorry guys, I have to also get in touch with the new students. Now, I was saying A was moving horizontally, so it had horizontal momentum. When it came to collide with these two, these ones took different directions. So they are experiencing a vertical component, and at the same time, they'll also experience a horizontal component, as I'm going to resolve, and you see. Now with this is what is going to happen. Horizontal momentum can be got from, we shall have M1 U1 is equal to M1 V1 plus M2 V2. But on splitting, V1 moves with, this one moves with the velocity V over 2. Okay? Then this one we have said we assume it's moving with Y. So you resolve horizontally, we shall have V over 2 cos of 60. So when you resolve this velocity V to this one, horizontally, you will have V over 2 cos 60. Then to the vertical, you'll have V over 2 sine 60. Okay? Then when you resolve Y to the horizontal, we shall have Y cos of theta. To the vertical, we shall have a negative Y sine of theta. Why is the vertical negative? Because it's going in the negative Y axis. So those are the components of velocities we desire to use here. So V2 is the horizontal component of velocity for M2. M2 moves along BD, which is going to be Y cos of theta. So when you substitute, you shall have, and remember U1 was equal to V, so we shall have M1 V is equal to M1 V over 2 cos of 60 plus M2 times Y cos of theta. So with this regard, we shall have what? M1, did we identify M1? M1 was 4 kgs. Was it 4 kgs? Let me see. 4 units, okay. It could have been mass number because these are atoms. So we shall have, they say the nucleus B of 4 units. Also A is of 4 units. Okay, both of them are 4 units. So M1 and M2 are the same. So we shall have 4 V is equal to 4 V over 2. Cos of 60 is a half plus 4 Y times the cos of theta. I can lose this 4 with that. Then I'll have V no, this 4 is still existing. So I have 4V minus V is equal to 4Y cos of theta, giving me 3V is equal to 4Y cos of theta, and call this equation 1. That is the horizontal component of momentum. Then for vertical momentum, initially, the vertical momentum was 0. So M1 times U in the vertical should give us M1 times V in the vertical, V1, plus M2 times V2 in the vertical. But Uy in the vertical was 0. So we shall have 0 momenta is equal to 4 times, the first one is going to be V over 2 sine 60 The second one has a negative 4 times y sine of theta. With this regard, we shall have 0 is equal to, by 2 ones, by 2, 2. So we shall have 2 times v root of 3 over 2 minus 4y sine of theta. I can lose the 2. So v root 3 is equal to 4y sine of theta. So for that reason, we have equation 2. This can be our equation 2. So having realized equation 2, I can divide equation 2 by equation 1. You will see that I have Roman 2 divided by Roman 1. This will give me 4y sine of theta is equal to v root of 3 over 4y cos of theta divided by 3v. I vamoosh the v, I vamoosh the y, vamoosh the 4, we shall remain with the tan of theta is root 3 over 3. Tan of theta is root 3 over 3 is the same as 1 over root 3 when you rationalize root 3. Therefore, theta is tan inverse of 1 over root 3. Calculator, what is tan inverse of 1 over root 3?
It's
30 degrees, right?
yes.
Okay, if it is 30 degrees, it means they are deviating at an angle of 90 between them, because now this makes it 90. With this 60, this one has 30. So having confirmed that, we can find also the velocity which they asked for, y. So for substitute back, we shall have 4v root 3 is equal to 4y sine of 30. Sine of 30 is a half. So this will give me 4y times 1 over 2, remaining with the 2y. So y shall give me root 3 over 2v meters per second. Since the first velocity was also in terms of v, so we can leave v in our answer as the solution. So with that, we have got that solution for that consideration. So that's what happens when particles are deviating from each other. If initially they were moving at a given velocity, then later on they end up colliding, and one takes a different direction and the other also takes a different direction from the original direction of the initial body moving. So we can download that unless if someone has a question.
They are gonna teach you.
Wow, it's almost.
Okay. Okay. I'm done a regular laptop.
So the last bit under this, I'm going to share some 3 or 4 numbers. One on momentum separation, like that one for those helium nuclei. The other one will be on a pendulum bob, for a ballistic pendulum. Now the last bit here is when we have force on a body or on a surface. And we look at momentum on a surface. Initially, the body can come with this momentum at an angle theta, and it leaves with the same momentum at the same angle. But now as it is moving, this momentum is equal and opposite. So the change in momentum so we have what we call forward momentum, which is mu. Then we have what we call the reverse momentum. The reverse momentum is the same but in an opposite direction. So the change in momentum shall be mu minus a negative mu. Muve ku motoka mugende. So this will give me so that's the change in momentum. Now remember, also recall impulse. Impulse is equal to change in what? In momentum. Which impulse is Ft is equal to now to mu. So the force on a particle, force will be given by 2 mu divided by the time it takes. These are some of the illustrations which occur when water is being shown on a wall. You get a pipe or you get a cable connected to the tap, a water cable. Then splash the water on the wall. The water will be deviated will be reversed in the same direction, in the different direction, at an angle which is the same angle as which you're pouring it to the wall, and it will come out with the same momentum. So you strike water on the wall, like this wall. Water, if it pours on like this, it will leave at that angle. So it comes at this angle, leaves at the same angle, because of the momentum conservation, which predicts that in this case the momentum is the same and all water is living at the same velocity and living with the same momentum, though it has reversed direction. And that time is the time for which the body is in contact with the wall. Like I've said, you can consider a jet of water striking a wall and does not rebound. The wall is said to have destroyed the momentum of the water. Now that is if the wall is rough, it will destroy the momentum of the water. But if it is smooth and we don't experience or we don't expect such forces to come in and stop the motion or control the motion, then there I would say it would give us the same like I've just derived. I will also send an illustration on this. Let's have one number on this case so that I can show you exactly what is happening. A ball of mass 500 grams traveling at 60 degrees to the horizontal, strikes the vertical wall and rebounds with the same velocity. At 120 degrees to its initial direction. If the ball is in contact with the wall for 8.0 times 10 power negative 3 seconds, calculate the average force exerted on the wall by the ball. So here is our number. I'm trying to illustrate what exactly it is talking about. The angle there is 60. They have said it has been diverted in 220 degrees to the initial direction. So if this is the initial direction, it has now been bounced off in that direction at 120 degrees to the initial direction. So this angle also is going to be what? 60. So they have said calculate the average force exerted on the wall, on the ball. So average force will be equal to change in momentum over the time. Which change in momentum will be? Remember, this is mu, this is negative mu. So to give us mu minus negative mu over the time taken, giving us twice mu over t. But if you look at these velocities, let me not just take it for granted, because next time you might land on a number which is a little bit more interesting than this one, whereby the angles would be required to critically resolve, and you get the point right. So the force would be given by 0.5, the mass of the ball, times the velocity cos of 60, minus a negative 10. Okay, negative 0.5 times 10 cos of 60, divided by the time, which is 8 times 10 power negative 3. Why does the velocity become 10 cos 60? It is because when you resolve the momentum horizontal like this one, it becomes mu cos theta. Likewise, when you resolve this one, it will also become a negative mu cos theta. That's where what I'm doing comes from. So for that reason, we can now deduce and say the cos of 60 is a half, so 0.5 times 5 plus 0.5 times 5 divided by 8 times 10 power negative 3. So from this case, the force will give me, this is a half plus a half, you get 1 times 5 over 8 times 10 power negative 3. And this will give me 5,000 out of 8. Therefore, force will give me 625 newtons. So that is the answer. So with this, we have entirely discussed what we call momentum. Perhaps next time we can talk about Newton's laws, or we can talk about friction. So let's have this and call it a day. Let me give you some few minutes. Unless if you have a question. If you have a question, you raise it. If you don't have questions, take some few minutes and download that as I prepare for my next class, which is for senior 6, because I missed their class earlier. Any questions?
I was reading somewhere and someone said women are not materialistic. If she's asking and you find what she's asking very expensive, then you're not for them. Please keep her for someone.
Mawa. Hello? Wanji Mawa. Ndi busy. Guys, I think you're fine. Eh? I can stop the meeting. Mawa. Chechiriwo. Mbadde ku Zoom naye nzo no mayiriza.